Hello everyone, my name is Andrew. Today we'll continue learning programming, and today we'll talk about a database per service pattern inside of microservice architecture. So let's start. Once again, today we'll talk about database per service, why is it important, how does it work, and where do we apply it. But first of all, let's start with the simple example of an architecture that is a microservice architecture. So we have something like an app, it can be a Django app, Node.js app, so your application, like a monolith application in one project. And then your app connects to the database. Pretty simple, pretty simple. Nothing to add here. Your application connects to the database and works with it. Everyone wrote those applications in their life, but not many people used microservices. So that is microservice architecture. We have our user. The user will go to our application here as well. So we'll go somewhere here, and we'll connect to the database to the application as well, just like that. But here in microservice architecture, what do we have here? Instead of one big app, we have different services. Don't look at the API, which is needed in order to make that all work. It's kind of like just an aggregator for all of the services in our program. But we split our big app to different services. For example, balances and orders. We have one service for balance, and we have one service for orders. And the microservice architecture brings a lot of pluses and a lot of drawbacks. So you need to be really careful with it. And because it brings a lot of drawbacks, we can't just start doing it because we want to. We need some reasons in order to really transform our application into a microservice architecture. And those reasons are as follows. First of all, when we talk about microservices, we want to scale them independently. So if we look at the app, imagine that our users want to query their balances a lot. So we have balances and orders here, but in our application, balances and orders go together. And if our user wants to query his balances a lot, then what we can do in order to increase the throughput of our application is to scale it horizontally. So add one application in another server and connect it to the database as well. But there is a problem, because we can't scale the code with balances independently. So I can just say, copy the part of the code where we have our balances, so where we have our balance logic, our user balance logic and all that stuff, and copy it to another server. We can't say that because our application is a monolith. We only can copy the whole application to another place. However, in microservices, we can do that. So if my user requests balances a lot, I can just copy that one server balances and leave orders untouched. So we can scale independently. Then we can deploy and develop our services independently as well. So if I'm talking about application, our users, not users, but programmers will have to commit and push all of the changes in one repository. So our application is one big repository, and we can't really define anything because it's just one big repository. It's not bad. But if you have a very big team and you have like 5,000 lines of code, then it may be not as good. Because if all the people from your development team push into the same repository, then you're going to have like a lot of conflicts, first of all, and you're going to have a lot of people who don't know what they're doing. Because if, for example, 20 people push to the same repository each day, then it's not going to work out because you have a lot of changes and nobody can track all of those changes anyway. So you can do that. But in services and microservice architecture, what you can do is assign different teams or different developers to different services. And that is one big thing that allows us to scale them and develop them independently. So there are a lot of other pluses in using microservices, but there are a lot of drawbacks. So one drawback is that we need to somehow join them. We need to think about the communication between them and all that stuff. However, our question today is, do we need to still use one database or not? So I explained that microservices should scale independently, should develop independently and all that stuff. But what about databases? Well, the answer is, you should use database per service. Of course, if you need the database. If your service does not require a database, then you don't need to put it. But what's the rule? The rule is that you should not allow other services get the information that does not belong to them. So for example, we have balances and orders here. Imagine that we need to query our orders and see the balance changes for those orders. So balances reflects the balance changes of our users. Orders reflects the orders of our users, two separate services. And if our orders service will go to the same DB as balances, what we can do is simply write select all from orders, if you talk about a scale, select all from orders where balances is something, or join by balances, something like that. However, why is it bad? Why can't we join and have the same database for orders and balances, or for any other service? Because when we're talking about microservice architecture, the only way to access the data for the service is to query the API of that service. So what we want to do in microservices is strictly split our application into different services. So we want to segregate services, their data, and all of the stuff that comes with them. They should be atomic. And because of that, if we have the same database and we query the tables and the data that belongs to orders inside of the balances, or we query the data that belongs to balances inside of orders, what are we doing is we're introducing dependencies. And what's the problem with that? The problem is that if you have your service that queries the data that belongs to another service, you can't develop those services independently. Because right now, balances is dependent on the schema of our orders. Orders are dependent on the schema of our balances. And there are tons of other examples that show you that it's really not the way to go. So if you have one database for separate services, then it's going to be really, really bad. Because, once again, if you don't access your service using its API, so using RPC calls, using commands and events, or some other sort of communication, so if you don't do it like that, so I go to services, service 2, so from orders code, and orders code gets the information that I need, then it's going to be really, really bad, because you introduce tons of dependencies. And that is why we have a pattern that is called database per service. So each service that requires a database will have its own database. And there are millions of reasons why. So I told you one, you have dependencies. Another reason is that if you want to scale your database independently, you can do that with service or database per service pattern. So you can copy database for the service number 2 and put the connection like that. You don't need to scale the database for the balances if your throughput is enough. So kind of like that, you can scale databases independently. Aside from that, what you can do is use different database products. So imagine that balances requires an SQL database. What we can do here is put an SQL database. But orders requires a NoSQL database. We can put NoSQL here. And NoSQL here as well. Kind of like that. So we can use different SQL and NoSQL products, different database products. And that can add a lot of pluses, but a lot of minuses as well. Because right now, if we're using different databases per service, we need to use some sort of transactional mechanism that will allow us to have a consistent state of our program. Because if our user has a request that changes both the balances and orders. For example, we make an order. Orders service should append that order to the database, but balances should be updated as well. So we should, for example, subtract the balance of our user. How are we sure? So how are we sure? What's the guarantee that both orders and balances will execute successfully? Because if orders service has a successful command, but balances fails, so we have an exception, or I don't know, database is not, we don't have a connection to the database, it's somehow broken, so database is offline or something, then it's going to be, then we have an inconsistent state, so we have our new order, but the balance was not changed. So you need to think about that. Then, of course, you need to think about joins. So if your user takes a data that contains both orders and balances, so data from both services, how are you going to join that data? Well, you need to answer all those questions, but typically, you're going to have, not typically, but almost always, you're going to have a database per service, because that pattern is the thing that allows you to develop microservices. If you have one database for all of your microservices, or for 2 or for 3 of your microservices, then it's going to be a really big problem, because you don't develop a microservice architecture. Your services are not atomic. You can't just remove one service and all the other services will work fine. Because, once again, your database exposes lots of dependencies to other parts of your system, and you have a distributed monolith, not a microservices. And yeah, kind of like that. That's how it works. Of course, it should not be a separate database in terms of the product, so you can use the same databases for all parts of your projects. And to be honest, it should not always be a separate database in terms of the server, in terms of the physical database. Because what you can do is have one database, but split schemas for different services. So for example, we're going to have a schema for balances and a schema for orders. Those schemas should not interact with each other. And if that's the case, then you're going to have a perfect example with only one database. So your database should not be like, or database per service pattern should not apply physically. You don't need to have different services or different servers with different databases. But what you should do is split the data and split the tables, documents, all that stuff, depending on your services. You can even have the same database with different tables, but you need to make sure that, the separate schemas are better, because if you have one database, you can have different schemas and so it's going to be fine. But be sure that balances, orders, and all the other services in your microservice architecture do not query the data that does not belong to them, and do not change the data that does not belong to them, because if they do, then it's going to be a really big problem. So querying is one thing, but changing the data that does not belong to your service is a whole other. And that is why database per service is a perfect pattern. Once again, it's not a physical pattern, it's a logical pattern. You need to really make sure that you don't expose any dependencies regarding your data. And kind of like that. So thank you for watching. My name is Andrew. If you have any questions, you can ask them down in the comments. But for now, thank you and bye-bye.